With 2 weeknight.
Yeah. So
PLO2 and 3.
yeah. So this is CSF 4203, chapter 19, week 10. Computer networks and security techniques. Allah Akbar, Allah Akbar. Ashhadu an la ilaha illallah. By the way, when you go from the PowerPoint, you can see the comments here, which are also very useful. I recommend that you also read them. Okay. So for security, we have 3 function areas. We have authentication. Okay. This is to assure that a received packet was in fact transmitted by the legitimate sender. Okay. Confidentiality. Enable communicating nodes to encrypt message to prevent eavesdropping by third party عشان ما حد يقرأ شو مكتوب أو يفهم شو موجود. Key management concerned with the secure exchange of keys, okay, and provided by the Internet Key Exchange Standard, okay, IKE version 2. By the way, we will do a lab for this on VPN. Okay, the current version for the book is IPsec version 3. Transport and tunnel modes. ESP support 2 modes of use. Okay, we have transport mode, provides protection primarily for upper layer protocols. Like what? Upper layer protocols. Yeah, application layer. HTTP, like that. Encrypt and potentially authenticate the IP payload, but not the IP header. Because IP header is not the upper layer, it's not the upper layer, network layer. Tunnel mode provides protection for the entire IP packet. So original or inner packet travels through a tunnel from one point to an IP network to another. No routers along the way are able to extend the inner IP header because they are all provided with that protection. It is used when at least one of the 2 ends is security gateway, such as firewall or router that implements IPsec. So this is the scope of ESP encryption and authentication. The transport mode here. See, the header is outside. Okay, so this is encrypted. With the tunnel mode, the whole payload is encrypted. Okay. Key management involves the determination and distribution of secret keys. I think you have done this in your cryptographic course, right? That's why it's a prerequisite. The IPsec architecture document mandates support for 2 types of key management. Manual. It is practical for small networks, but if you need to go for bigger organizations, you need to use the automated method. Okay, automated enables the on-demand creation of keys and facilitates the use of keys in a large distributed system. Which one did you use in crypto? Did you use the automated one or manual? Remember? Both, huh? Did you use software for that or only theory?
No. Yes, we used it on project.
And the project itself. Okay. IPsec and VPNs. The driving force is the need for business and government users to connect WAN or LAN infrastructure in a secure manner to the internet, because we need to access the internet. The internet by itself is not secure. We know that. With IPsec, managers have a standardized means of implementing security for VPN. And because IPsec can be implemented in routers or firewalls owned and operated by the organizations, the network manager has complete control over security aspects of the VPN. And when I am doing VPN, I am doing the configuration because I own the equipment. I don't need to go through the telecom company. SSL, which is Secure Socket Layer, it is designed to make use of Transmission Control Protocol TCP to provide a reliable end-to-end secure service. It is not a single protocol, but rather 2 layers of protocols. Okay, this is the SSL. SSL architecture. SSL record protocol provides basic security services for various higher layer protocols. And then we have the Hypertext Transfer Protocol, HTTP, which provides the transfer service for web client service interaction. We know about HTTP. And it can operate on top of SSL, as you can see here. See HTTP on top of SSL. 3 higher layer protocols are defined as part of SSL, which are Handshake, Change Cipher Spec Protocol, and Alert Protocol. Okay, Handshake, Cipher, and Alert. Any questions? So this is the operation of the SSL record protocol. You can read down here. The first step is fragmentation. Each upper layer message is fragmented into blocks of messages. Then they are compressed, but it is optionally, yani not necessarily to be compressed. Then you compute a message authentication. Okay. Next, the compressed message plus the MAC are encrypted using symmetric encryption. The cryptographic concepts referred in this chapter are discussed. We are not going to go deep into this. You have already studied this in your crypto course. But we are going to do a lab on IPsec VPN. Inshallah. Not today, but maybe after, next week maybe, or the week after. Handshake protocol characteristics. This is the most complex part of SSL. Okay, it allows the server and client to authenticate each other and negotiate an encryption and MAC algorithm and cryptographic keys to be used to protect data sent in an SSL record. Okay, and they should be done before any data is transmitted. Of course, they have to agree on the handshake protocol to make sure that the link is secured before I start transmitting my data. I think this is clear. The handshake protocol phases are: phase 1, it is used to initiate a logical connection and to establish the security capabilities that will be associated with it. Then we have phase 2, okay, and the details depend on the underlying public key encryption scheme for that is used, okay, or maybe it will use certificates. Phase 3, client sends one or more message back to the server after verifying certificate. Okay, only if it's verified. Phase 4, complete the settings up of a secure connection by signaling to both parties that the exchange has been successful. So the handshake is completed. For Wi-Fi communication, we used to use WPA. It is based on 802.11. Okay. And it was taking care of authentication, key management, and data transfer privacy. Okay. This is the 802.11, which is Wi-Fi operation phases. Okay. You see here we have AP. What is AP? AP, low access point. Correct? AP, yes. Access point. So this is how the authentication is done between the station and the access point or the laptop. Okay. So first, an exchange between a station and access point. It enables the two to agree on a set of security capabilities. Okay. Then an exchange involves the AS and the station provides for secure authentication. So even for Wi-Fi, we have to have these security operation phases. Okay. Unfortunately, we are not doing a lab for Wi-Fi authentication for this course. Now we will come to a new topic, which is intrusion detection and intrusion and security intrusion. What is the difference? Security intrusion, yani there is an event, something happened. Detection meaning that you need to know, to be aware of it, yani to feel that something happened. Okay. So by definition, intrusion is a security event or a combination of multiple security events. Okay. When there is a security incident in which an intruder gains or attempts to gain access to the system or network or data. Intrusion detection, it's a security service that monitors and analyzes system events for the purpose of to find and provide real-time or live warning of any attack from hackers. Okay. Alaikum. And we have different types of IDS. We have host-based IDS. It monitors the characteristics of a single host and the events occurring when that host, within that host for suspicious activities. So this is host-based. We have also network-based IDS. This monitors the whole network traffic. Okay. And analyze it. What are the logical components of an intrusion detection system? It has sensors to collect data, analyzers to determine if an intrusion has occurred or not by analyzing the data from the sensors. Then, of course, we have the dashboard, the user interface. It enables the user to view output from the system or the analyzers. Okay. This interface may equate to a manager, director, or console component. Yani send messages even. Triggers, alarm, or something. Okay. What are the basic principles of operation of the IDS? If an intrusion is detected, quickly enough, the intruder can be identified and ejected from the system. Yani you can disable his login, kick him out. Okay. Also, an effective IDS can serve as a deterrent. بيحكوا الوقاية خير من العلاج. When you have IDS, hackers will be afraid to attack you. Maybe. Okay. Also, intrusion detection enables the collection of information about intrusion techniques that can be used to strengthen intrusion prevention measures in the future for training, for documentation also. Host-based intrusion detection techniques. Host-based IDs. It adds a specialized layer of security software to vulnerable or sensitive systems. It will monitor activity on the system in a variety of ways to detect suspicious behaviors. So the primary purpose is to detect intrusions and log suspicious events and send alerts. Okay? It can detect both external and internal intrusions. Very good. That's the host-based. Especially for sensitive systems. And you have importance of system server. You want to add a host-based software to it or protection to it. Firewalls. We all know about firewall. They are inserted between the network and the internet. And at the border, I have my internet here. Sorry, my intranet here. Firewall, then the internet. Okay. It provides an additional layer of defense, insulating the internal system from external networks. What are the design goals for a firewall? Any traffic, inbound or outbound, okay, must pass through the firewall and examined. Only authorized traffic as identified by the local security policy will be allowed to pass. So you will configure a security policy for the firewall. And the firewall should be also strong enough and immune to penetration. مو يجي الهاكر and kills your firewall. There are different firewall techniques or types. Service control. It determines the types of internet service that can be accessed, inbound or outbound. No, firewall, you can prevent email, correct? Or you can prevent HTTP. Allow only HTTPS. Direction control determines the direction in which particular service may be initiated and allowed to flow through the firewall, inbound or outbound, the direction. User control, which user is allowed and which user is not allowed. Behavior control, control how particular services are used. Okay, this is very important slide here. Okay, so here we have types of firewall. We have packet filtering firewall. Okay, packet filtering firewall. Let me go inside here. All right. Try to maximize it as much as I can. Okay, the first one to the left, A. Okay, so here we are filtering according to the packet. We have also a stateful packet inspection firewall. We have application proxy firewall, and we have circuit level firewall. Okay. Good. Next. So, what else can we do to protect our network and our systems? Antivirus, of course, right? What does the antivirus do? It will do prevention, detection if something is infected, identify what is the type of password, and try to remove it. Okay, detection include also alarming, giving you alarm. What is this? What's going on? We have also worm. You know the worm in network?
Yes.
It propagates. Does not need a file. Huh? Once a worm is resident on a machine, antivirus software can be used to detect it. Worm propagation generates considerable network activity, and you can find that your bandwidth is consumed or compromised. Network activity and usage monitoring can form the basis of a worm defense. Administrators typically need to use multiple approaches in defending against worm attack. It's very dangerous. The countermeasure focuses on identifying suspected worm content or identifying the traffic pattern, because I know if I get this traffic pattern that there is this type of worm. Okay. Any questions? This is the last slide. Okay. Any questions on this chapter?